Today we'll be doing an experiment to look at the Chatelier's principle. And the principle is fairly simple, but let's talk about what it first means to be at equilibrium. If you have a reactant and it is in a chemical reaction that begins to proceed, let's say, in the forward direction, then what ends up happening is eventually you build up enough product that the reverse rate of reaction balances the forward rate of reaction. And in a sense, we come to this standstill in the concentrations. The reactant concentrations no longer go down, but the product concentrations no longer go up or down either. So what ends up happening is molecules are continuously being produced of the product, and in the reverse reaction, molecules of the reaction are being produced at the same rate, and this is where we get the idea of equilibrium. So Le Chatelier was studying effects on chemical equilibria, and he came up with his principle. And the principle is basically this: if you disturb a chemical equilibrium by adding or removing or changing the reaction conditions, what the reaction does is it tries to compensate for that change. So in a simple sense, if you remove a little bit of product, it'll try to make more product. But if you remove a little bit of reactant, it'll try to go back and make more reactant. They were studying this in the context of maximizing amount of product you could produce. But we're going to study it sort of more on just the observational level. We're going to be doing a series of chemical reactions, changing conditions, and then looking to see how those changes can be observed in the chemical reaction. And then we'll summarize our work in a series of statements for each reaction. So with that, I will let you sort of explore the procedure, and I'll get started with the experiment. So, before we get started, this is one of those things I'll say in class, but it's not the way the lab is actually recorded. Oftentimes you're asked to get a certain volume, and this is a test tube with 3 mils of volume in it. For these qualitative experiments, like Le Chatelier's principle, where you're not trying to make quantitative measurements, you're making observations, this actually serves as a pretty good reference for the volume. The counting of the drops very much depends on the size of the pipette tip and what you're dispensing out of. So having said that, I'll add the potassium dichromate to match the volume. Again, that's 3 mils on the right, and when I get about that volume, I'll stop. There, and that's 3 mils on the left. So now we're ready to start our experiment. And I'll add 2 to 3 drops of concentrated hydrochloric acid. I'll shoot for 2, but occasionally, it doesn't quite work out how you want, so refocus that. I'll add the 1 so you could see before any mixing takes place. Okay. And hopefully you can see that color change. Then I'll add another 1. Actually, these are like little half drops. There, I got it in there. A little bubble in the pipette tip. And then we'll mix it up. Take it out. You tap it on the side, it'll vortex the solution. So there's the color change. Now, when you write your observations in your notebook, telling me what color it looks like doesn't help. What you need to say is what it looked like before you added whatever you added, for in this case hydrochloric acid, and then you need to talk about what it looked like after. So the description of the chemical reaction is describing the change, not just what something looks like. So now I'll add sodium hydroxide. That was about 3 drops of hydrochloric acid. And this is 6 molars sodium hydroxide. 1, 2, 3. I don't know if you can see this. The sodium hydroxide is very dense. Went straight to the bottom. So now I'm going to mix it. And I'll add, this is 4 drops, 5 drops, 6 drops. I'll go up to 8, 7, 8. Okay, so 3 drops of hydrochloric acid at 12 molar, and then about 6 to 8 drops of sodium hydroxide of 6 molar. That's what we just did. Fill another tube, but this is for the acetic acid dissociation portion of the experiment. I need about 3 mils of deionized water. So I've got that. That's my reference I removed. And I'll place this in here and I'll make my additions. Okay, so I'm going to add 1 drop of methyl orange indicator, and I'll try to do this fairly precisely. I don't want too much, it'll be too dark. So there's my 1 drop of methyl orange, and then we'll agitate it a little bit, get it distributed. Now I'm going to add 1 drop of 12 molar hydrochloric acid. Molar hydrochloric acid. And then we're going to add 4 drops of the 6 molar sodium hydroxide. That's 1. 2, 3, 4. So next what we'll do is prepare 2 test tubes this time with 0.1 molar acetic acid, and we'll do 3 mils in each test tube. Take away the water one because they're easy to confuse. Now, two drops of methyl orange to each tube. And we're going to keep the tube on the left as a reference. So now I'll continue to work with the single tube. And I'm going to add 10 drops of 1 molar sodium acetate. Oops, let me grab it and I'll stir it like this so you can see that color change a little better. That was 3, 4, 5, 6, 7, 8, 9, and 10. And now we can hold up our reference tube next to it, and you can see the difference. For this next part, we have 4 test tubes labeled A, B, C, and D. And we're supposed to make a solution in a beaker, 100 ml beaker. We use a 1/2 ml of ferric chloride, or ferric nitrate, sorry, and a 1/2 ml of potassium thiocyanate. And then they're both 0.1 molar. So I'm going to go ahead and just do 3 drops of each. And then we're supposed to dilute this to 50 or 60 milliliters. So I got some water I'll add. And the important part is we're going for a color intensity, sort of a peach color. So I think that might be okay. I'll add a little bit more. Like that. Now we're going to fill each of these test tubes up to the 3 ml mark. So I'll stop the video, and when I start it, they'll all be filled, okay? So there's tubes A and B, and to tube B, A is your reference. I'll add ferric nitrate to tube B, about 10 drops, which for this dropper is about 1 ml. Now, tube C. And to tube C, I'll add potassium thiocyanate, 10 drops. And then to tube D, I'm going to add sodium hydroxide, 6 molar, and 5 to 10 drops, which is really in this dropper size 2 to 5 drops. So. A couple of more just to keep going. Okay, and then we can look at all tubes side by side. Sorry, bugs me when the labels aren't straight. So we're going to add cobalt chloride, about 3 mils, to this test tube here. So we'll measure it out here. And then I'm going to add 1 drop of water to it. It doesn't usually take much, and I'll need to get a dropper to do that. Okay, so 1 drop of water, and let's see what happens. Okay, nothing. It's 2. This is a much smaller dropper, so it's adding really small volumes. 3. One more. Okay, we'll go with that for now. May have to come back and make adjustments to this. Now, what we're going to do and stick it in a hot water bath, and we'll observe what happens. So we'll go right over to the hot water bath. This is all prepared already. So. Okay, so it was about to boil, so I took it out. But that is the color that we have. And next thing, I'll set up an ice bath to show you what it looks like when you stick it in ice. But what I'm going to do is I'm going to leave this on a time lapse so that you can watch it in the room. So that was on time lapse. I don't know if you can see it or not. Let's go ahead and stick it in here, get it really cold. It's kind of a cool bath, not a really ice bath. I might try something a little colder here. But there we go. That's what it looks like now. All right, you can go back in the video and compare to what it looked like before. So for this part of the experiment, I need 4 mils of saturated sodium chloride, so I'm just going to use a pipette for that. This is 2 mils. This is 4. There we go. 4 mils saturated sodium chloride. And then we're going to add concentrated hydrochloric acid to it. And I will stay far away from it. Stuff that guy in the middle. So you can see that solution right now. In fact, what I'll do is I'll zoom. There we go. Okay. Now I'll put it on time lapse and you can just observe. All right, so I don't think you could see anything, so I got rid of the time lapse, but here's what we have. And so you can't really see it until you go like that. And what we got is little crystals formed at the bottom. Okay? So we're going to do the calcium oxalate equilibrium. So calcium chloride goes into each tube. Again, 3 mils. A is the reference, and we will take and add potassium oxalate to tube B. These drops are big, so instead of the 8 to 10, I will do 4 to 5. So 1, 2, 3, 4, 5, and that should be about right. Okay. And to C, we're going to add oxalic acid. Again, in line with what I did for the first one, I'm going to put 5 drops in. 1, 2, 3, 4, 5. And for tube D, I'm going to add oxalic acid again. It says to do 6 to 7, so I'll do 4. And then 6 molar ammonia to do 4 or 5, so I'll go to like 4. Scaling, well, maybe I'll do 3. 1, 2, 3. Okay. What you're supposed to take note of is to look at the amount of precipitate that forms in each. And really the best way to do that is to allow it to settle and then make your observations on the solution. So we'll do a time lapse for about 5 minutes. Okay, so let's pull these out of the oven and see how they look. Sorry, I like cooking. Well, A is there, okay. It's pretty clear. There's B. There's C, and you can see right at the bottom, there's a little bit of solid in there. And there's D. You can see there's more like down in there. It's a little cloudy, hard to see. And just, I know this takes a long time to settle, so I actually ran them earlier. It's a little bit clearer, and this is B, C, and D for another. I did the experiment earlier actually because I knew it would take a long time to settle, so that result might be a little clearer to interpret, okay?